Brett sells thingamabobs to two types of consumers. It tells us there's 10 type 1 customers and there's 20 type 2 customers, and then it gives us the value function for each customer. Thingamabobs cost Brett $3 per unit to produce. Suppose Brett can separate the customers by type and charge them differently. Further, suppose he implements block pricing, offering different size packages and different prices to the two types, only allowing each type to buy the package meant for them. How many units does he include in the bundle or package he sells to the type 1 customers? So this question is only asking about type 1 customers, and therefore we can ignore all the type 2 customer information. Remember that in block pricing we want to capture all the consumer surplus and cover all of our cost. And so let's look at a linear demand curve to help us visualize what we're solving for. We notice that in this graph we have a straight line drawn for inverse demand, and we have our marginal cost curve drawn, and we see that we want to produce at Q star units and charge a single price equal to this entire blue area. That blue area is equal to the total value at Q star units. Well, this question is only asking us to find Q star, so we won't have to solve for our block price. But if we did have to solve for our block price, we would plug in Q star into our total value function, and that would be our single block price. But again, we're only solving for Q star. To solve for Q star, we need to first solve for our inverse demand curve and then set inverse demand equal to marginal cost. So, starting from our total value function, we find inverse demand by taking the derivative of the total value function, and we see that its price equals 28 minus Q squared. We know that marginal cost is $3, so we can plug in 3 for price because we're setting those two lines equal, and we can solve for Q, and we find that our optimal Q star in this case is 5 units.